Okay, as a reminder, something I've said multiple times. A, no iPads out, but B, I will record video notes of all the notes that we do. That way, if you're ever absent, you can watch them and see what you missed. Or if you're like, oh my gosh, I'm taking notes on paper for the first time and I didn't write everything down, there's a YouTube video to help you out. So that does mean, way back there, there is a YouTube video on recording us right now. I blur out everybody's faces and all that stuff, but it's there, so just be aware of that. I figured that's the best place for it because otherwise it blocks somebody's view of what's going on. So, today we're going to start our first lesson on physics. So far I've only taught you about graphing. That's not physics, it's just a tool we need to help with physics. But the very first thing we're going to talk about is something called reference frames. Reference frames. I'll even underline it with that. Here's the deal. Our goal today is to learn different ways we can describe motion. Okay? We're going to learn everything up through speed and velocity. We're going to talk about motion in those ways. We'll wait a couple class periods and add on acceleration, and then we'll have everything we need to describe any type of motion. The whole point of our physics class is to first describe motion, this unit. Then we're going to learn why the motions. Then we're going to learn how the motions. And we're going to get really good at motion. Then we talk about fluids. That's pretty much what happens. So, to describe motion, the first thing you have to do is define your reference frame. You have to decide how you're going to reference and describe the motion you're talking about. For example, if I stand over here, right, and you want to say, hey, Miss Lima was standing over in the classroom. Well, first off, you've defined me as being inside the classroom, so that was something you referenced. I'm not outside the classroom, I'm inside, so you've already decided that. You could reference me as being really close to this countertop. You could reference me as being 5 meters away from my desk there. You could reference me being in this corner. But either way you're going to describe my location, you're going to do that by referencing something. So that's the idea behind a reference frame. Before we can talk about something, we have to define how we're going to discuss it. So the first thing we define is a starting point. You can decide this to be whatever you want, but we all have to decide so that way we know. So for example, for today, this is going to be 0. I'm going to move only to the right and to the left. But this is going to be my starting position. This is position 0. So whenever I reference my location, I can say I'm 2 meters to the right of 0. I'm 4 meters to the right of 0. By defining that starting point, I can define my position. So that's the first thing you have to do. Next class, you're going to get a car, and you're going to watch the car go across the surface. And you have to decide, is this going to be 0, where the car starts? Or is where the car ends going to be 0? Or somewhere in the middle? You have to decide that reference point to start with. Now, most of you are just going to say it starts at 0, because that's the easy thing to do. But you do have to consciously make that decision. Okay? The second thing you have to do is decide which direction is positive and which one is negative. So if again I go back to the car you're going to play with next class, right? And it's going this way. You're watching it go that way. You're going to say probably that's the positive direction. It starts at 0 and that's positive. So maybe it goes 3 meters positive. That's probably what you're going to set up because it's like the easiest thing to do. And the good news is you get to decide that. It's up to you. You can decide whichever direction can be positive and whichever direction can be negative. Important to know. AP can also decide that. So when I talk about reading the full question, when I get an AP test question, I can't just assume that I know what directions things are. At the end of the question, it might say, oh, and that way is the positive X direction. Okay, if you said it, it's true, right? If you said it, that's true. Okay? So, that being said, There are some general directions and definitions that we pretty much all agree to use so that life's simple. There are situations where you might break these. Maybe you're dropping something and you don't want to deal with ugly negatives, so you say that down is the positive direction. Great. I don't care. But these are the ones that you can assume in any AP question or any question I give you, unless told otherwise, or unless in the lab you decide otherwise. And here they are. We're going to move in the X and Y direction. So in the X we have right, and in the Y we have left. Right's going to be positive because it's the positive axis in math class. So we're like, let's just keep things the same. Why make it hard? Left is going to be negative. When you look at the word left, this is not about physics. When you look at the word left, what does it also kind of look like? Look at it. If it weren't the word left, what would it look like? Something else. Anybody? Nobody? Does anybody see 6 feet? Yeah. That's just how I write the word left. So if you ever look at the board and you're like, oh my gosh, what is Miss Limer writing? It's not 6 feet. I don't ever use feet very often at all. And probably not 6 of them. So it's left. I will do that occasionally from time to time. I'll write in a word problem on the board and say, Susie's going left. And you're like, Susie went 6 feet? No, she went left. So that's just a fun fact about Miss Limer that you should know. That's left, not 6 feet. All right, what about up? Do we think it's positive or negative?
Positive.
Positive. Very nice. And down should be negative. Very nice. We will also need this with the cardinal directions. So that would be never eat soggy waffles. Never eat soggy waffles. So those are the same, positive, negative, or north and south, and east and west. Okay? Now, fun fact, we live in a three-dimensional world. We are three-dimensional things. So in our class, we're going to stick to 2 dimensions, the X and the Y. X could be left and right, forward and back, east and west, but we're still typically going to stick with those 2 things. We're going to launch projectiles eventually in both directions. What we don't deal with is the Z direction, which would be this one, right? So we have X, we have Y, we don't deal with Z. Take C, we'll talk about Z. Take 2, we'll talk about Z, but we don't do that in this class. Questions about directions. So this is just something we all have to agree on before we start. Otherwise, if I tell you I'm 6 meters to the left of where I started, and you have no idea where I started was, you're going to be like, I don't know where you are. Right? So that's reference frames. Questions about this? Okey doke. Erase this. Very exciting. Last thing we need before we can dive into some definitions about physics are these words scalar and vector. Certain things that we discuss are either scalar quantities or vector quantities. Scalar quantities are magnitude. You're like, I don't know what magnitude means. That's okay. It means number. Only. It means whatever this is can only be described by a number. That's it. Versus a vector can be described as magnitude and direction. Exactly. Magnitude and direction. So me driving on the highway, I can describe as, hey, I'm going 20 miles per hour south. That's a vector quantity. That would be my velocity. If I'm going 20 miles per hour south, I'd be going negative 20 mph. Speed, if I just say my speed and I look down at my speedometer, I can say I'm going 70 miles per hour, but you don't know how fast, like which way I'm going. I'm just going 70, right? That would be speed. Other examples, scalar things, how many cars are in the parking lot? That's a scalar. It doesn't have a direction. Those cars are just there. They don't have a direction, right? Lights on the strings in here, that's a scalar quantity. Doesn't have direction, right? Vector has to also have direction. So when I say I'm standing here, right? I'm standing here. I'm doing this right. This is the left, right? Left. I said left, right, but this is the left direction. I'm on the left side of the classroom, yes? Yes, okay, good. I'm at negative 2 meters from our starting point. Right? That included direction. I didn't just say I'm 2 meters from our starting point. That might be a scalar thing. I said I'm 2 meters to the left. I'm negative 2 meters from our starting point. That would be vector. Okay? Questions about vector and scalar? One thing you'll hear a lot is that scalars can't be negative. And that's roughly true. I'm going to say you can count on that. 99.999 times out of 10, a scalar quantity is not going to be negative. So speed is never going to be negative, ever. You're just going to say, yep, I'm going 20 miles per hour. Don't know which direction, can't be negative. Is there one chance that it could possibly be negative? Yes, but the context of that I can't even think of right now. But I don't want to guarantee 100% something that I know isn't. All right, after all those directions, definitions, information, let's do physics. First thing we want to describe is where we are and how far we've come. So, we're going to talk about position. Position is location. That's all it is. It is my location. It is a vector quantity. It is a vector quantity because I can label it as positive or negative position. Am I to the right or left of my starting point? The variable I use for that is x or y. And the unit I use is meters. I say x or y because I can talk about my position in terms of x or of y. So, if I stand right here, I'm roughly negative 3 meters. That's my position from the starting point. I'm negative 3 meters. That's my horizontal distance. If I go up here, now I'm like 0.7 of a meter positive, right? From my 0, 0. In the vertical direction, I'm 0.7 of a meter vertical. And now, I'm going to go in a negative direction and get back to 0, right? So that's why position can be x or y. Depends on which way I'm talking about. Am I going horizontally? Am I going vertically? Questions about position? All right, next up is displacement. Displacement is my change in position. Over here. It's also a vector. Since it's based on a vector quantity, position, this would also be a vector quantity. We're going to see that a couple times today. Its unit is going to be change in x. Ooh. Delta means change. So for displacement, since it's a change in position, I literally write out change in position. So it could be delta x or delta y, and it's still in meters. If you want an equation for this, if you're like, I love equations, they make me so happy that I can define things really well, then here's an equation. Delta x is equal to x minus xo. What this is saying is my displacement is equal to my final position minus my initial position. That's what that's saying. You'll notice in AP, we use xo as our initial position. Should it be xi? Honestly, I like xi better, but here we are. AP uses O, so we're going to use O. They figure it means original position, which is fine. You also might see I might slip up and write F on final. You're also allowed to do that. Just because it's not on your equation sheet that way doesn't mean you're not allowed to do it. But if you really need help remembering, final can be F and initial can be I, but this is how AP is going to write it. Final is just X, my current position, and initial has that O for initial. Yeah. Questions about this? Let's do an example. Here I am. I'm at 0. What is my displacement if I walk 5 meters this way? Walked 5 meters from 0, 0. What's my current displacement? 5 meters. Positive 5 because I went to the right. Right? Yeah. Perfect. Awesome. All right. If I keep going and I go 3 3 meters past 0 over here, what's my current displacement? Negative 3. Okay? How far have I walked? What's my distance traveled? 8. Okay? Those are two different things. Displacement and distance are different. So distance is the last thing we're going to put on here for how we describe where we are. Distance is how far an object or you has traveled. You will not see this unit on the equation sheet at all, or this variable at all. You will not see an equation for this at all, but it's typically D, and it's also in meters. There's no real better way to find distance than to just, okay, how far did somebody go? If Susie walked to her house and back, and then she walked to her friend's house and back, she's walked 6 miles, even though her displacement is now 0 because she's back where she started, right? Distance is just how far an object traveled. It's a scalar. Sure is. Scalar, it's not going to be positive, or it's not going to be negative, it's only going to be positive. Questions about position, displacement, or distance. Position's where I am. Displacement is how far I've gone from where I started, and distance is how far I've actually traveled. All right, last 2 words. Last 2 things. We've already talked about them out in the hallway. We have speed. Speed is how fast am I going? Speed is how fast am I going? Let me give an example. I love this example. There is a cheetah crouched in the savannah, because that's where they belong. There's a cheetah crouched in the savannah staring at a deer. Sees the deer, wants to eat the deer. Thinks, that sounds like a good snack. So my cheetah runs 300 meters in 3 seconds. What is the speed of the cheetah? How fast is the cheetah going? Yeah.
100 meters per second.
100 meters per second. Okay? Let's talk about this. Was the cheetah going 100 meters per second the whole entire time?
Probably not.
No. Because what was it doing at the beginning?
Accelerate.
It was at 0, and then it had to accelerate, right? It was staring at its meal, and then it had to leap into action and start going. So while it covered a distance of 300 meters in 3 seconds, that's going to be its average speed. This over here, so 300 over 3, this would be an average speed. An average speed is the distance over time. That's what average speed is. And we can only calculate average speed. I don't know. Aside from its initial velocity, I don't know what the speed of that cheetah was every second it was running. We'll find out in a couple of class periods that we could also calculate its final velocity from its average. But those are the only 2 things I can know. Its initial speed and its final speed. And its average speed. At some point in the middle, I don't know.
Good afternoon, CHS. My name is Ashlyn Porter, and my name is Lydia Nolan, and we are your Red Jacket Ambassadors. Please stand for the pledge. I pledge allegiance to the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. And now for the Texas pledge. Honor the Texas flag. I pledge allegiance to thee, Texas, one state under God, one and indivisible. And now for a moment of silence. Thank you. Students, today we have a hidden chess meeting in the auditorium after school at 4:50. Be there for your important information. Also, as a reminder, make sure you buy your homecoming tickets now. The price will increase on
speedometer. Speedometer can get us our current speed. If we put a speedometer on the cheetah, maybe. But there is one on our car. Also, we're going to use motion detectors, motion sensors, and those can tell us our actual current speed or velocity of whatever object we're using for that trial. So there are a couple things that we can use to get it, but based on, hey, this is how far Susie ran in a certain amount of time, that's always going to be average. Last thing, velocity. Yay. Velocity is speed, so it's the same thing, plus direction. It's how fast am I going and in what direction, okay? Similarly, the actual velocity of the cheetah is unknowable in the middle of its run. But we can find average velocity, which is v is equal to delta x over time. So that would be average velocity. We'll do an example next class showing how we can use initial velocity, average velocity, and time to find final velocity. There might be a test question.